We are talking about function operations, and here we have f divided by g of x. So we have the function f, in this case, is 4x to the 2/3, and we're going to divide that by g of x, which in this case is 5x to the 1/2. So right off the bat, we can see that we have x that's in the denominator. So whenever the denominator is equal to 0, our domain is limited there. So we take our domain, or whatever's in the denominator, and we say 0, when is that going to be equal to 5x to 1/2? So we can divide by 5. Then we get 0 is equal to x to 1/2. And to get rid of that 1/2, we square it. And then we get 0 is equal to x. So in this case, we're trying to find what x cannot be. So x cannot be 0. You could have looked at this and said, oh, 0 is going to make this bottom 0, so I'm just going to pick 0. But if it's not that clear, all you do is take the value that's in the denominator, set it equal to 0 and see what it is, and then that's what the denominator cannot be. So right away, we know that our domain is restricted. It cannot be equal to 0. Now we're going to continue on. Because we're joined by division, we can combine the x's here. So 4 divided by 5 is 4/5. And then we have x to the 2/3 minus 1/2. Well, in order to combine those, we have to have them in like terms. So 4/5 x to the 4/6 minus 3/6. And so that's going to be equal to 4/5 x to the 1/6. And now we're taking a look at our function that we have here. And really what we have written is we have this part right here says the 6th root of x. And so the 6th root of x is going to limit our domain because we have an even radical. And so this limits our domain, and it says x must be greater than or equal to 0. So this takes away the negative numbers, and this says our domain cannot be equal to 0. So in this case, the domain that we're going to pick for this, we have the domain is a set of all x values that belongs to the real numbers such that x cannot be equal to and must be greater than, so x must be greater than 0. Or if we want to write it in interval notation, 0 is not included all the way to infinity.